Okay, everyone. I am Shiv Prakash, Research Scholar, Department of Electrical Engineering, IIT BHU. Let's start the session. Harshvardhan,
Yes, sir.
please off your mic. Please.
Okay, sir.
Good evening, sir.
Good evening. Good evening,
Sir.
sir. As I explained, some questions from assignment number 3 and 2 suggestions for assignment number 4 also. This is the first question. Which of the following is it true about the MOSFET? I think everyone know about the MOSFET. It is a charge rate control device. It is a charge control device, 4 terminal devices. Across the gate source terminal, a negative voltage cannot be applied, or it has an internal body diode.
Sir, the answer is B, D, and E.
B, it is the gate charge control device. Yes, and it's a 3 terminal device. And D, I think you can't apply the negative voltage. Yeah, this one also true. And it has an internal body diode. Yes.
Sir, what the first one? It is a charge rate control device, right, sir?
Charge rate, it means dq by dt.
Yeah, that
This is a current control. But MOSFET is not a current control device. It is charge control. Charge control means Q is equal to Cpa. If you control the charge, then voltage is control. That's why MOSFET is called about the voltage control devices. This one.
Thank you, sir.
No, simple structure of MOSFET. This one SiO2 layer, and this one is the source. This one drain, and this one is the gate. VDS, VGS. Here is source, drain. This one substrate. The source directly connected to the substrate. For operation of the MOSFET, because of voltage applied through the gate VGS, then this current flow like that. And this one present holes. First neutralize the electron and find a layer here.
That is the inversion.
Yes.
The green layer is the inversion layer.
Yeah. That's why source connected to the substrate, and then push the electron here. Then he neutralize here and find a channel between the DN source and current flow like that. That's why substrate connected to the source. And here is charge control due to the voltage across the gate. And this is a 3 terminal device, drain, source, and gate. this one drain, this one gate and source. This terminal are known about the substrate. This one connected to the source like that. So simple N channel MOSFET. And last one has an internal body diode. If you apply here, remove it, and if you apply here this one positive, this one negative terminal to VDS, then this one connected to the positive and substrate connect to the here source. It means this one is a positive and drain is a negative, then it form a PN junction diode here. Like this one is the internal body diode of MOSFET. When you apply the negative voltage to the VDS. Yes, have any questions? Rakesh Rai?
No, sir, it's fine, sir.
Okay, fine. Then this one is correct. And this one 3 terminal devices. Because the gate source terminal negative voltage cannot be applied, yes. And this has a body diode.
Sir, we can apply the negative voltage. Na? In data sheet, you can see that there is a plus minus 20 volt gate to source.
Minus, I think,
To turn off. We can apply, sir. If you see the data sheet of the MOSFET, you will see plus minus 20 volt.
Yeah, it is not mentioned about the channel, then we can. This one is wrong because of the channel is not specified in the P channel MOSFET. It also can apply the negative terminal voltage. But in bit data is also mentioned about the minus something to positive 20 volt. Yeah, okay.
Sir, the diagram you have drawn is for P channel.
Yeah, this one is P channel MOSFET. No, this one is N channel MOSFET, sorry. N channel MOSFET.
Sir, but in N channel, then the drain has to be connected to the N.
Yeah, this one drain, na? This one connected to N, and source also connected to the N.
Okay, sir. Thank you.
And you have also know about the MOSFET characteristic. You know, this one is the forward blocking. If you not applied the voltage across the gate, then it's going to blocking the voltage. And if you apply the gate, then current will flow. And in the negative direction, you can't apply, can't block the voltage. Because of the diode, the current will flow. And MOSFET characteristic is like that, IV characteristic. And here is given question number second. Which of the following option would provide the exact following characteristic? It means same as the MOSFET characteristic.
Sir, if it is a negative gate source voltage can be applied if it is a P channel MOSFET.
Yeah, this one P channel MOSFET.
But for N channel, only positive gate source should be positive, right, sir? Always N channel, for N channel MOSFET, the gate source voltage should always be positive, right, sir?
Yes. Here, see about the question. A option. With this one BJT, if you apply here some voltages, then this one a forward bias. This one block the voltage. This one okay. So current will flow. Reverse it in reverse direction. It can't current flow. This will block the voltage. This will also come in here. That's why this is not correct. MOSFET is okay. So an IGBT with a external diode. This one the 4 coordinate. This is not correct. I think B and the C is correct for the second question.
Actually, the D option, so the last option, in that it can't block the voltage at all, right, sir?
Yeah, not a, but this configuration means you apply the voltage and block the voltage like that. But in this configuration you can't block the voltage. If you apply here positive terminal voltage, then current will flow from the diode of second MOSFET.
For
Then
both
this
the
will
polarity,
not,
it won't block.
yeah, you can't block the voltage.
Okay.
This means block the voltage. This is the current flow.
Okay.
In this here, it means that it not block the voltage. Application of RGBT. RGBT is a bipolar voltage blocking capability. Yes, you can blocking capability. Reverse blocking also have. You can't flow current in reverse direction, and in forward direction you can block by the gate. G voltage. Unipolar voltage blocking? No, it's a bipolar voltage blocking. RGBT is a bidirectional current device. No, it is a unidirectional current. Actually, in IGBT, it does not have an internal body diode. We add a body diode, actually as an external body diode for working, but in internal body diode it does not have. The IGBT is a unidirectional current device. Yes. So dynamic characteristic similar to the MOSFET. Yes, you can see it is similar to the MOSFET because you get same thing applied to gate. And IGBT has a dynamic characteristic of BJT. No, BJT is a different.
Sir, IGBT is dynamic characters is similar to BJT, is right?
Yeah.
Sir,
Actually,
how, sir?
the base current has a negative current also, sir.
In BJT have a negative base current also, but in IGBT is not a base current. I so gate to apply to the positive current.
Okay.
Is given which one the following the configuration is a 4 quadrant switch. 4 quadrant means you can block the both voltages and the current will flow in the both direction. If you see here option number A, then it has
Sir, one thing, all the questions now you are telling seems to be from the assignment only. I hope the solution for the assignment will be published in the portal. And we expect some thing relevant to the upcoming due assignment, which is from rectifiers and filters.
okay. Next
which is due on 22/2.
and
The assignment solution will be published in the portal in the sense then the live session can be covered with some other topic, right?
Okay.
Thank you. It's a suggestion. Thank you, sir.
I have taken from the assignment number 4 questions also as per your suggestion. Don't worry. Here I want to solve the question number assignment number 3 for your help. How the solution, how will it solve? You know about the here In option number A, you can't block the voltages, then you only current flow in the both direction. Same thing happen here also. So this one is the BJT. You apply the some base voltage, then you will block the voltage in both directions because of BJT is here and current flow in the both directions. So 4 coordinate is operation. Same thing here also, 4 coordinate operation IGBT here also because of in deep-pillar connected BJT IGBT.
Sir?
Yeah.
Sir, the last question.
Yeah.
In question number 4. Sir, in that D option.
D.
Yes, sir. D option.
Yeah.
When the transistor on the left side is blocking the voltage.
Yes.
With collector terminal to be positive and the emitter to be negative. Sir, that same polarity of voltage appears across the transistor on the right side also, with emitter being positive and collector as negative.
This one IGBT, not a transistor.
Okay, sir.
Yeah.
Anyway,
if you can't apply the gate voltages here, then it is a blocking curve. All of voltage blocked there. Here, only this one working in the forward direction. If you apply a voltage like that, and the gate source is not applied, then it will block the voltages. And when the gate voltage apply here, then the current will go.
So that's okay, but for the transistor on the right, what is that? The source terminal is positive and the drain terminal is negative.
Yeah.
In that case, how will it block? If in that case, if you are not providing gate signal to the transistor on the right, will it block that voltage, sir? Or
yeah, it will block voltage.
Oh, if you are not giving gate voltage, then both the polarity of voltage will be blocked in the drain source.
Yeah.
Okay.
This one this is IGBT, na.
Yes, sir.
And the MOSFET also, you apply the negative VDS, then MOSFET can't flow, na, if your diode is not present. But in MOSFET, you have a diode, internal body diode. That's why it's a flow a current. But here is not current flow in BJT, IGBT.
Okay.
That's why this one the 4 coordinate.
Okay, sir.
Voltage current bidirectional. Bidirectional switches means the voltage and current characteristic is same in positive and negative direction. MOSFET is not the same direction. In MOSFET, you block the voltages, some voltages, provide the gate that you P12 characteristic, but in negative voltages, the diode is conducted and current flow like that only. And this is not the same characteristic for the MOSFET in the positive and negative voltages supply. IGBT also not the same, only positive direction current flow. Diode can flow in both directions in the same characteristic like that. As means two diodes connect in parallel. If you apply a positive voltage, then this one contact. You apply negative voltage, then this one conducted. And this configuration, VI configuration, like same current flow like that in positive and negative direction. Same thing apply for the track. Either replace a diode from thyristor. So also bidirectional BJT diode in bidirectional. It is same. It is not the same characteristic in positive and negative direction. Okay. Here question number 6. A diode is connected in series with an LC load. On the figure, with a capacitor having an initial voltage 20 volt, capacitance 10 microfarad and inductance is 40 microfarad. If the switch is closed at T equal to 0, determine the conduction time of the diode. At T equal to 0, this one is on. This one is the is a high over 20 volt initial voltage. It means this one connect to the positive, negative, diode will on, and current flow like that. I rewrite this one. In a capacitor with initial voltages, you can written like that. This one a capacitor. Then VC not VC. Then see if you connect, if you change in transform the Laplace, then find this SL. This one given by SC. Current flow like that. Very current IS Laplace. This one VC not by S as the initial voltage. Laplace condition. IS into LS plus IS to 1 by S is the capacitor. VC naught. This one a Laplace transform. That's why using S in the bracket. S common, and S square into LC plus 1. SC will cancel out. Find current into C divided by S square LC plus 1, common of LC, CC cancel out. Find IS is equal to VC naught divided by L S square plus 1 by LC. To apply the inverse Laplace transform, you arrange the some quantity like this one is you can take root of LC square, same as the LC. Here is the divide and multiply by 1 by root LC. And find VC naught into, if you take over 1 by root LC, let omega something, to omega divided by S square plus omega square to under root L by C. You know this one is the Laplace transform, the sine. So go to C by L into sine omega t. The current flowing through the inductor or the diode. You can rewrite this one as the maximum current IP VC naught C by L. Then you find the final current expression is like IP sine omega t, Im sine omega t, like this one is AC signal. Observe this one. If you apply DC in LC tank circuit, then you find a sinusoidal current. And the question asks about the determine the conduction time of the diode. I written omega t time scale in theta. This one current flow like that, I t in sinusoidal. Okay. If the flow, if there a diode is present in the circuit and current flow go reach the pi in a half cycle, and is go to negative cycle, but it's not a negative because of the diode conducted, is current will remains 0, only pi conducted because of the diode. Diode can't flow a negative current. The same if you find a VL and a VC, you know about the voltage of inductor. VL is equal to L di by dt. Indicate this one, L into I, this one VC naught into sine omega t, means cos omega t into omega. There is 2L square connect cut off, CC also cancel out. Then final inductor voltage is VC naught cos omega t. It means it will form like that. VL is like, after that is 0, and VC is equal to VL because of the capacitor. This one is the whole capacitor voltage. Overall this one is capacitor with a initial voltage. Then you take this one, that is a VC, capacitor voltage. And this is equal to the inductor voltage. VC is equal to VL. That's why this one is the same waveform. After this one, the current is 0, inductor voltage is 0, but capacitor remain as VC not again initial voltage this one. Because diode is turn off, and inductor voltage is 0 because of the current is not flowing. Inductor voltage can change suddenly change, but capacitor voltage does not change sudden change. Conduction time is pi. You can find the conduction time omega t is equal to pi, and pi is equal to t time pi by omega. Omega is 1 by root LC. You can put the value of LC and find the time, conduction time. Same thing, put the 10 microfarad and 40 microfarad and find. You can also find the average and RMS value of the current also for the same. I have another questions in the following circuit diagram. Let us assume all the elements are ideal where the initial current flowing through the inductor and initial voltage across the capacitor is 0. Same thing, but separate voltage sources applied. Then what will be the current and voltage waveform of the capacitor and inductor? In previous question, the separate voltage source is not applied. Is the voltage source working? The initial voltage of the capacitor is working like a voltage source. But here is a separate voltage source applied. Then what will be change in the waveform of all? Same thing apply when t is equal to 0. And all initial condition is 0. Then circuit behave like that. B, C and L, current will flow like. If you transform the Laplace, then you find P by S 1 by LC, sorry, by C. I think this one is a question from assignment number 4. Some of the question and some of the different question. Apply the KVL in the circuit and find minus Vs by As plus Is into 1 by Sc. Sorry, this one is Sl equal to 0 and Vs by S is equal to same Is 1 by Sc plus Sl. Take Sl common here. So take Sc is LCM and then find 1 plus S square LC divided by Sc. SS cancel out. take LC common here, then we find 1 by LC plus a square is the same as the previous question, divided by C, C cancel out. Find I is equal to Vs divided by L 1 by SC. Else this one the same as the previous question, that's why I written directly. It is equal to Vs under root C by L into sin omega t, where same as sin omega t, omega is under root LC. Same as the inductor voltage, VL is equal to L di by dt. Same thing we find Vs sin CS cos omega t. You differentiate this one, and VC will change. VC is equal to Vs minus VL, and Vs minus Vs cos omega t, then Vc will be Vs 1 minus cos omega t. There is some question asking about this one, like a conduction time and what is the capacitor voltage, final capacitor voltage. Sorry, I'm not good in drawing. That's why. This one current I is equal to IP sin omega t. Same thing, LC circuit and sinusoidal current flow. But a diode present here is present, that means current flow at 180 degree only. After that, this one current is 0. VL same one, Vs cos omega t. Here. After this 0. This one Vc capacitor voltage. Remember, capacitor is Vs 1 minus cos omega t. One minus cos omega t means, if you draw here, at omega t is equal to pi by 2, it means cos omega t cos omega t is 0, cos pi by 2 means value is 0, then Vc is equal to Vs, this one, Vs, and at omega t is equal to pi, at omega t is equal to pi, cos omega pi is minus 1 and minus plus 1, then Vc is equal to 2 Vs. This one is Vs, this one is 2 Vs. The capacitor voltage remain at 2 Vs, supply voltage. When a diode is off, the capacitor voltage is twice of the source voltage. From here we found an equation to say that. And inductor voltage appears zero. This one is a 2 Vs. Next question is given here. The following circuit diagram, let us assume all the elements are ideal, where the initial current flowing through the inductor is 0. If the switch is going to be closed at
Sir,
yeah.
sir, the previous question, what is the nature of the source? Can you show me the
DC
question?
voltage. DC voltage.
Okay.
Only DC voltage. If DC voltage apply at LC circuit,
Okay.
okay, then you find a sinusoidal current.
We are deriving a transient period.
Yeah, this one is transient. No. I written as steady state.
Sir,
Yeah.
in previous two questions, the answer of the T is equal to 62.8 microsecond.
This one.
Whatever you have discussed, this one and previous one. Both the time the current is going to cease after omega is equal to omega t is equal to pi.
Yeah, both are same.
Both are same.
Yeah.
So T is equal to pi into root LC. That is the
Put the value of LC, then you
of
find.
if the same LC value is there, then it will be the same.
Yeah. It does not depend on the voltage source.
Not on
amplitude.
depend on yes, not dependent on voltage source as well as amplitude. Okay. If the voltage is there or not, it will cease after that root LC.
Yeah, if there is in the question number first, the initial voltage capacitor is there, and then question number second is the source voltage applied.
Yes.
Okay, the next question I am taking in the following.
काय ते असेल
The sinusoidal voltage apply in the pure inductor circuit, then what will be the conduction time? Anyone guess? The voltage source is the sinusoidal.
Sir, initially there will be no change. There is no current because of the inductance.
Why?
It will not allow the sudden change. No, sir?
Yeah, but
So it is
the
asking
current flow
only
like
T codes.
from zero, na? And current flow can from 0 to some value. It does not sudden change, but it can flow from 0 to something value. Na?
Okay, sir. Okay.
Okay, let's see what happened. Same thing circuit. When switch is on, I applied a sinusoidal signal, then only inductor is present here, current I, and then Vs. You know VL is equal to Vs, and Vs is equal to Vm sin omega t. And no VL is L di by dt. And di is equal to Vm by L into sin omega t into dt. Apply integration both side plus some constant. And this one current, so no minus Vm by omega L into cos omega t plus k. At initial is not given, initial current is not given, that means 0. Then at t is equal to 0, I will be 0, I was 0. Then we will find k is equal to Vm by omega L into cos omega t . then I will be minus Vm by omega L plus Vm by omega L. Sorry, here t is equal to 0, then cos 0 is 1, and cos is not present. Vm by omega L only. Then I will be, if you common Vm by omega L, then 1 minus cos omega t, the current equation. And the voltage is same, here is equal to Vs. Zero, pi, 2 pi, 3 pi, and 4 pi. This one is Vs. I take this one IL. Vs is same as VL. Left it. IL is given, I is Vm by omega L into 1 minus cos omega t. Then find t is equal to 0 omega t, then I will be 0 at omega t is equal to pi by 2, then I will be Vm by omega L, with some value Vm by omega L take as a constant value, so pi by 2, so some value Vm by omega L. Yeah, we can also retain like IP is a peak value or something, and we find easy current equation is equal to IP 1 minus cos omega t, and simply we put here IP, and when omega t is equal to pi, then I will be 2 IP, so current magnitude will double. This one IP, this one 2 IP. Omega is equal to 3 pi by 2, cos will be 0, and same thing this one IP, and when omega is equal to 2 pi, omega t is equal to I will be 2 pi is means cos 0 means value 1, 1 minus 1 is 0, then can flow like that. It means it will be conduct 360 degrees diode, because current will form like that. Current is not going in negative, then diode cannot off. diode can conduct, okay, hold the cycle. If a pure inductor is applied to the AC source, then diode will not disconnect it, or they all will conduct it in the whole time. It means that in one cycle is a 360-degree diode conduction. Here because of a current sudden change, here if you current at a pi current is a 2 magnitude is double in the magnitude, then can sudden zero the inductor current. That's why diode will be on, continuous on, and current flow like that. If you then if you when you ask about the conductions, the conduction is the 360-degree. You can also see here if the average current is not equal to 0. Conductor average current is not 0, but conductor voltage is 0. Inductor voltage is 0. Average inductor voltage is 0. That's why average power of the through the inductor also 0. But average current is not 0 in inductor. But in capacitor is average voltage is not 0, average current is 0.
So they are asking for the conduction time.
Yeah.
So it always conduct means in time sense, how will you calculate that?
No, you can say for one cycle is a 360-degree na. It here is the 0 na current at a 360-degree. That's why you can.
So here it means that diode will be on forever.
Yeah, you can say like that, but at 360-degree is a 0 current. That's why you can say conduction time is 360-degree.
360.
Yeah. Okay.
Sir, could you please go to 7th problem once again? I have.
7th.
Yeah, that the continuity 7th and 8th. Sir. Here I want to know the excitation voltage, nature of the excitation.
And the question number this one.
Yeah. No, that thing before this one. 7th.
DC voltage.
DC voltage.
Yes.
DC voltage applied to the LC circuit.
Okay.
And when the DC voltage applied, then the current behavior as AC, not a DC in LC circuit. If you if any resistors connected here,
okay,
then if you calculate the current, then current behavior happening like that.
Yes, still. Right.
In a damping nature. It's a practical circuit. Yeah.
The same thing is for the 8th or 9th. 9th also it would be same.
Yeah. This one is because of the exponentially.
Exponential.
Okay.
This one work and I think class B computation. If you read a class A computation, there you can see this.
Okay.
This type of effort.
Got it.
Excuse me.
Yeah.
This in the same problem, there is a resistor, that is why it is damp type.
Sorry, can you comment in the chat box, please? Your voice is not clear for me. Yeah, can you repeat this question?
In the circuit, there is a this is RLC, I think, no?
In the practical circuit, there is a RLC, but I will take only LC circuit here.
Yeah, this one here, it is a R and LLC.
Yes.
Because of this resistance, it is a damping type.
Yes.
And if resistance is not there,
then this one is sinusoidal in nature.
Okay, and this will be continuous.
Yeah.
Oh,
And there's a damping resistance depending on the resistance value. The over damp and under damp are critical damp.
okay. Thank you.
And it's a pure sinusoidal, it means a critical damp only, resistance is not provided. And over damp and under damp depending on the L or C and R value.
Okay.
We will have a repeated cycle on this. Oh, what we have said.
This one.
Yes, the
This
waveform.
one, when diode is not present, that's time this one is correct. When a diode is present, then
Only one
conduction
cycle.
only one half cycle.
Half cycle.
Yeah, this one only. If a diode is not present, that time you see in the transmission line like that. In transmission line, when the switch is on, then you find this type of behavior. Then the switching voltage is very high, and you know about the second harmonics, all of things is included there. The next question. A single phase diode based rectifier supply a highly inductive load of 10 ampere. Then what would be the peak value of fundamental component of input current? Highly inductive means this is a load current is constant. If highly inductive mentioned in any question, it means their output current will be constant. You will know about the full bridge rectifier. I draw once. So Vs, D1, D2, D3 and D4. Vs, Vm sin omega t like that. On this in positive circuit, D1, D2 will conduct and will go to negative cycle. Then D3, D4 is going to. I mentioned a voltage polarity at reference only, because the AC is not a polarity fine, but as a reference I will take a positive negative. All the question you can do from the waveform. If you draw a waveform, you can draw, then all of the questions you can give an answer. This one omega t. No voltage supply. And draw for 2 cycle, pi, 2 pi, 3 pi, so no 4 pi. Sinusoidal, and this one is positive, then output voltage or voltage is coming. This one is D1, D3 on, sorry, D1 and D2 here, and here D3, D4, and again this one is D1, D2. Then output voltage same as input voltage waveform. This one is a Vs, supply voltage. Same as waveform. Can you say what is this one value? Vs or minus Vs? Anyone know about that?
Sir?
What is this? This one is the Vs is coming on the output voltage, and here what is this one? Vs or minus Vs?
Vs only.
Vs.
Yes.
Yes.
Only.
If you put a Vs like that, okay.
Yes.
Once you calculate the average voltage, what you find? Like that, this one. If you take the average voltage, na, this 0 to 2 pi, then 0 to pi Vs sin omega, this one, Vm sin omega t, d omega t, plus this one also Vs, you can say like that. Then pi to 2 pi, Vm sin omega t. You integrate this one, then you find a average voltage.
Vm by pi.
But this one
Vm.
but if you integrate like that, then you find a zero voltage. Please do yourself if you want to try this one.
Here you want to put minus Vm no, sir.
Why minus? That's why. This one is Vs signal, na? Vs. This one is a Vs only, na?
No, if you want to write as pi to 2 pi, then that Vm should be minus Vm.
This is not a Vm. Vm is a positive value only. Vm is a positive value.
Voltage.
You minus positive coming from the angle only, cos, the sine angle. Vm is the positive value. Yeah, this one. That's why this one I take a polarity like that. No, this one is V naught. Okay. Look here. This one D1, D2 on, and current flow like that. Okay. Then plus Vs connected to the V naught. Okay. Same thing if in negative cycle, if you take D3 and D4 on, then current flow like this one, na?
Yes.
Okay. Current flow in a negative direction. That's why I've taken our as a polarity for reference only. I say in the starting, this one if you find the V naught is a minus Vs, because this one positive connected to the negative, and negative is connected to the positive. That's why V naught is a minus Vs. It means you say that this one is the Vs, and the minus Vs is this one. That's why I say like only polarity way. This one is minus Vs. Then this value is come in the output. Then you say, that's why you take as a negative for the minus pi to 2 pi. This was a Vs and this was a minus Vs.
Sir, we are taking load voltage now, sir.
Yeah, load voltage
The
only.
load current direction is always the same, no? Then
This one I draw, na? This one the V naught only. When a diode will conduct D3 and D4, then you find this one positive, and positive is connected to the negative of the source, na? and negative is connected to the positive of the source. That time when D3 and D4 is on.
Yes, sir.
Don't be confused. This sinusoidal is not a positive negative, but as a reference I will take. I am taking as a reference file only. For a reference, then you find like that. This one is coming in the outputs. Yes, this was the output. If you take a same Vs and Vs is equal to Vm sin omega t only, that time you can say like
Yes, sir.
yeah. So
Okay, sir. How to find the peak component?
okay. I think I am disconnected. Wait some time. Okay, it is visible.
Yes, sir.
Hi, sir.
Okay.
Excuse me, sir. Hello.
Yeah.
Sir, actually, the current is flowing reverse direction to the load or not?
Yeah.
Only we are taking for reference.
In the load, current is flowing in the positive direction only, not a negative direction.
Um,
Load flow current is the same. This one.
Same there.
This one is only current flow like that only. Once flow like that, and second time this one.
Okay, only one direction.
Yeah, this
Right.
one direction. I load current. I not this one highly inductive mentioned in the question. That's why I naught is the same. There is a constant I naught. Then what is the IS current?
This is here, excuse me.
Yeah, yes.
Highly inductive, we have taken the ideal one.
You can say like ideal, but you mention in the highly inductive means take a current as a constant.
Okay.
Yeah. If you simulate this one in the MATLAB and some any other, if you take a highly inductive load, then you find like as a constant output.
Okay.
Or the current in input side.
It will have positive and negative.
Yeah. When current is flowing this direction, in D1, D2 is on, and D3, D4 is on, the current flow in the negative direction. This one is the IS. And this one I naught. So minus I naught. And flow like that. Then the question asked about the what will the peak value of fundamental component of input current? This one is source inductor, source current. But this one is not a fundamental, this one is overall, all of current. Here the harmonics are present in the input side. That's why this one is the square waveform. For any waveform, find the fundamental value, then you can apply a Fourier series expansion. You know about the Fourier series? Xt, A naught or some DC value is present. and n is equal to 1 to infinite an cos omega t n omega t plus bn sin n omega t. But we know about the half wave symmetry and symmetry waveform or half wave symmetry like that. Odd even, know about the odd even also. Odd wave.
Yes, sir, it is an odd waveform.
So odd means if you apply x minus t, then you find minus xt. This one odd, and even means you apply xt. It means this one apply a minus xt to find xt only. In the board, I tell it the simple way like that. In y-axis, right hand and left hand is the same symmetry, the mirror, current mirror like that, the waveform. Then is the symmetrical waveform. And the odd, this one is the that one is the odd waveform. Like that, this one, if you know about the cosine signal, this one is the sorry, this one is the even signal. If this one minus, it means not the same in right and left half in y at y axis. That one is the odd waveform. If y axis is the same for the left and right side, then you say like a even. It means a cos signal. Cos omega t, you can say this one the even signal, and the odd is like a sine signal. This is not the same, and this one is the same part. If you keep a mirror in the y axis, then you find the same waveform as the right hand. That is the even signal. If it is not the same, this one is the odd signal. And if our odd signal, one other symmetry is given half wave symmetry. Half wave symmetry means xt is equal to minus x t plus minus t by 2. It means you can shift the signal at half time period. After that, this one is if this one is the symmetry. Look into this waveform. I take as a reference here. If you take this one is 0 as a reference. Shift the t minus 2 waveform like t by 2, which means half of. Total time period is 2 pi. Then t by 2 is pi, and shift this signal is pi. If this one is shift here, then you find this one is shift here, then you find next one signal impose here, coming here. If you shift like that, plus t by 2, and this one negative signal. When negative apply, then this one is the same imposes to the this one signal. This waveform. It means this one is the half wave symmetry. If this is not matched exactly, that means it's also not a half wave symmetry.
Sir, explain this again.
Now half wave symmetry, first one you apply a plus t plus minus t by 2 signal. If you take any signal, if you take this one, okay, shift this one only, shift t by 2 means pi. If you shift the pi positive, advance or delay, if you take advance, then this one come here. I take another. This waveform come here. If you take if you shift this one at a pi, this one is shift a pi, this one is pi. If you shift here in pi angle, then this waveform shifted here. After that, you apply a negative.
Okay.
Negative, then this one waveform same as imposes with the
Okay.
original waveform. If this is a happen, if any waveform, then that time there is the half wave symmetry. And it means there is a half wave symmetry, and this one is a odd signal. If a half wave symmetry and odd signal is there, then in the Fourier analysis, half wave symmetry and odd signal. If a half wave symmetry happens, it means A naught is equal to 0. If a half wave symmetry present in any signal, any waveform, it means A naught will be 0. Not that here does not present the
DC component.
DC component. DC component will be 0. You can also observe from this one waveform, if a positive and negative is the same, this one positive, this one negative, you add for one cycle, then this one the DC component is 0. This one also DC value is 0. You can say directly, but some type of signal you can't say directly. That's why they are used for half wave symmetry. Like if any signal, if half wave symmetry is present, it means DC value is 0. And after that, yeah.
Sir, can we verify this half wave symmetry at any time? At all the times.
Okay. This one waveform, you can choose any of the waveform.
Okay.
One of the section. If you take this one, shift pi in delay. So this one shifted here, I think. You shifted here. You take a pi, and after that take a negative of this one waveform. Then this waveform goes to down. Then imposes to the original waveform. It's the same as original waveform. This one.
Okay.
That's why this is the half wave symmetry. For Fourier analysis of inverter and rectifier, this one is a very important thing for half wave symmetry and odd signal. Look, here you can simply calculate one component and directly say the Fourier analysis. If you don't know about that, this one you calculate the A naught, A n, B n, all of things. This will take a very long time. That's why I tell about this one. If a half wave symmetry present, then next is the odd and even signal. Odd signal, take a mirror on the y axis. If it is the same and right hand, this is one even signal. If it's not same, then it's the odd signal. Sinusoidal, this type of signal is the odd signal. And cosine is the even signal. This one is the odd signal because of the, if you take a mirror here, then this one is the not same here. So, it is the opposite one. That's why you can't see this one is the even signal, this one is the odd signal one. That's why if a odd signal present, then A naught is equal to 0. Only Bn present. You calculate Bn and find the Fourier analysis. If even signal, then Bn will be 0. And find An and calculate all of the Fourier analysis. Fourier series you can find from only one calculation.
Sir?
Yeah?
Sir, here I have a doubt. If both An and Bn are there for a particular waveform,
yeah,
how to find the fundamental of that waveform, sir?
Take this one, na? 1, A1, find A1 and B1 and add both one. Add the both.
Yes, sir. How to arrive at that magnitude of that fundamental if both A and B has?
You should add both one, A1 and B1. for the fundamental, because of the n1 present here, fundamental here also.
Okay.
Then you should add both a1 and b1. a1 plus a1 is the fundamental. This one is not in the fundamental.
Okay, sir.
Then our signal is a half wave symmetry, and a0 is 0. Odd one, it means an also 0. Only find a bn signal. Then you know about the bn calculation, 2 by t integration of 0 to 2 xt into sine n omega t into d omega t.
It's dt, sir.
If time you taken in the degree, then you simply take a d omega t. I will take a time period in degree, na 2 pi. If you take it in time in second, then you put this one dt. Two by 2 pi integration I0 this one 0, our original signal 0 to pi, this one 2 pi, then 0 to pi is I0, pi to 2 pi minus I0, then 0 to pi I0 xt, this one is the current IT, sine n omega naught omega t d omega t plus integration of pi to 2 pi minus I0 omega t one by pi. You can common I0. If you integrate the sine omega t, find cos n omega t divided by n from 0 to pi minus of cos n omega t pi to 2 pi you put value here n pi, so this one n also, because of this one common n, then we put a 0 here. If this one is a negative in any equation in integration for limit, if there is a negative value, then first one put lower side, after the upper side, then this one is correct. If it then positive, then first put a higher value upper side, and I put a 0, and cos 0 is 1. Here is 0, it means cos 0 is 1, and minus cos n omega t is pi, it means cos n pi so minus is positive, then you can say cos 2n pi minus cos n pi. Cos 2n pi minus 2 cos n pi. Say small. Look here, if n is odds, means 1, 3, 5, like that. Then you find Bn is equal to I naught divided by n pi. You know cos 2n pi, it means
1 minus cos n pi.
first one 1. If you take a 2 pi means 1 plus 1 minus this one 3, sorry, this one 1, the cos pi, if you put a 1 only for check, then this one is the 1 because of 2 pi means 0, cos 0 value 1, and n is equal to 1, cos pi means -1 and 2i plus 2, and you find 4 I naught divided by n pi. If n is equal to even, 0 also, 2, sorry, left 0, 2, 4, 6 like that. Then you put a 2 here and find 4 pi, and this one 2 pi. 2 pi means 60 degree. Here 1 plus 4 pi also 0, cos 0 is 1 minus 2 pi same as 360 degree, cos 0 will 1 minus 2, it means this one is a 0. It means is the in half wave symmetry is present anywhere, then even terms are all of 0 in, so in the odd signal, sorry, if odd signal present, then all of even term is 0 in odd signal, and in even signal odd term is 0. This one is the odd signal, that's why even term, all of even term is 0. Even harmonics is 0 in half, can say single phase half bridge rectifier, sorry, single phase full wave bridge rectifier in highly inductive load, then even harmonics is not present. Only odd signal is present. Then I naught and IT. What is IT? IT A naught, same thing, Fourier analysis. Fine, A naught is 0, An also 0, only Bn present, Bn sin omega t, and Bn is you know 4 I naught divided by n pi Bn sin n omega t. This is the current, and n is equal to 1, 3, 5 like that. It is asked about the fundamental I1. I1 means n is equal to 1. Then I1 is equal to n is equal to 1. Here peak I1 is equal to 4 I naught divided by pi sin omega t, and peak value 4 I naught divided by pi. This one is the peak value. This one is the fundamental. Okay, let's also say this one is a useful current only for in AC signal side. In AC side, and all of the terms are in the reactive. Sorry, this one is the useful. This is not a useful all of term like second harmony, third harmony. This one only for the heat produced. It is not a useful.
Excuse me, sir.
Sir, actually this fundamental is the useful thing, sir.
Yeah, this one is useful. You can also find the RMS value also. I1 RMS is equal to same thing, Vm by root 2 and Im by root 2. Multiply, divide by root 2 here, and find the RMS fundamental, RMS value of fundamental component. NSE side. Fundamental means Vm sin omega t, same as the same waveform as the source voltage, like that. This one.
Excuse me, sir.
Yeah.
Here the n is equal to 1, 3, 5, so on. How many n is it, how much n is enough to make it to simulate the waveform?
Sorry.
See, n is 1, 3, 5, so on. Many up to large number we can take. But for practical purpose, how many harmonics?
Infinity.
No, that is ideal case, infinity. But when we calculate it, how many up to which harmonic is sufficient to simulate the waveform?
I think 7 to 8.
7 to 8.
Because of the all of magnitude is very less, na? If this one is n present here in current.
Yes, yes.
Yeah.
Yes, yes.
You can also check here. If you apply the 10 here, then all of fundamental is 10th of the fundamental is a 10th harmonics. If there is a 20th and 30 is a very less value compared to the fundamental.
So you told that this fundamental component, they only produce the output. Yeah.
This one
And
useful,
harmonic component is the losses.
Yeah.
So how to find out the harmonic loss from this analysis?
So THD is there, na? There is THD. You can find a THD.
THD. Okay.
This one is give to this one is a 48% for phase. I think for a single phase. In 3 phase you apply, then there is a 31%. For full phase rectifier.
Whether it is if it is 31% THD, what does it mean in terms of losses?
Yeah, this one is the useful, I think. So this one is the losses. THD it means losses. You can you should reduce this one THD.
We can say if 31% is the THD, so 31% will be the loss of the fundamental.
Yeah, this one is loss of fundamental.
Okay.
Overall.
Sir,
yeah.
Here in our case, the calculated fundamental for 10 ampere ID.
Peak value here.
Here the peak value is ID is that I0 is 10 ampere.
Yeah, okay.
So 4 into 10 divided by pi is equal to 12.7 ampere.
Yeah, I think this one.
That is peak value of fundamental.
Yes.
12.7 ampere is fundamental peak amplitude, and RMS will be somewhere around 8-9 ampere.
0.95 2 root 2 divided by pi.
Yes. Which is coming around 9 ampere.
Yes.
Sir?
Yeah.
Sir, in that you said that if the given signal is a half wave symmetric as well as it is odd, then the even harmonics will be absent.
Yes.
The other ways, if it is half wave symmetry and even, then the odd harmonics will be absent.
Yes.
Then it will be absent in both AN and BN, if it is there.
Absent in both A1 and BN. It means a DC signal only, voltage DC supply. This one, if you apply this one, if you calculate this one Fourier losses, you can do, then you find only A naught signal. V and BN both are 0.
Okay, sir. So that even harmonics are absent, we are saying no, sir. That is applicable to both AN and BN, right? That is A2, A4 and B2, B4 all will be absent. All will be 0 if the signal is half wave symmetric as well as odd.
Only odd signal also present. This one means not required to have a half wave symmetry.
No. Yes, sir. Only
odd. If an odd signal means you have absent of the distance. Yeah. odd harmonics. Sorry, odd harmonics only present and even upside. Okay.
Okay, sir. Thank you.
Sir,
Yeah. Yes, sir.
here this input side current is means positive and negative type.
Yeah, it's square
Plus
wave.
I naught and I naught. Output current is unidirectional side. I naught.
Yes, sir.
In this case, how to find out the input power factor? Because input side voltage is sinusoidal,
Yes, yes.
and this current is square wave.
Yes, sir.
So it will affect the power factor, input power factor.
Yeah, they totally affected power factor. You
Because
know about the fundamental displacement factor at THD factor?
No, sir.
Okay, don't worry. For the upcoming lecture, I can explain you in some of the questions. Because of THD is
Because
not
it is
also
said that
here.
harmonic is there, input power factor it will affect.
Yeah. This one is G into cos alpha.
Okay.
Cos alpha depending on the switching for the thyristor. If you thyristor, then alpha is the triggering angle. This one is the power factor. This one is the displacement factor. G define the THD. G, this one G1. The fundamental RMS divided by total RMS.
Okay.
IS1 RMS divided by IS RMS.
Sir,
Yeah.
these circuits are mainly for thyristor bridge rectifiers.
The cos alpha only. This one alpha.
The cos alpha. When we are drawing the I0 constant as an inductive load.
Yeah.
But this is mainly concerned with the thyristor phase angle control rectifiers.
Yeah.
Or it is for any bridge rectifier.
This one for the bridge rectifier only. If you apply for thyristor, then this one is not present for a whole time period. No? This one alpha something somewhere. Only this one signal present.
Okay.
And this one only present like that.
Gotcha.
This one alpha signal is not present.
Alpha signal.
That time this one is alpha is in picture.
This will get modified. I0 will get modified.
Yeah. I can explain
It is
further. I can
Okay.
explain you.
Okay.
Design a full width rectifier capacitor circuit for the following specification. AC means 250 volt, 50 hertz with a tolerance of 5%. Output power is 100 watt. Maximum source current 2 ampere, and maximum ripple across the capacitor is 20 volt. I think this one is the assignment question.
It seems to be. Yes.
But data will be changed.
Yes.
This one is AC. This is a filter capacitor for doing the constant output voltage to reduce the ripple of the output voltage. So this one R, this one V0, C, D1, D2, D3, D4. V is equal to Vm sin omega t. I give a hint to this, solve this question. I can't solve all of the question because of this on a live assignment. Same output signal, I have fully output. After that I rebuild this. If capacitor is not present, then this waveform will come in the output. But when capacitor is present, it means in this one, it have some voltages, capacitor voltage. When this voltage, Vs voltage, greater than the capacitor voltage, here appears, then Vs, this voltage is greater than this one voltage, that time diode will be on and output current flow, sorry, then this one current flow, Is. When the supply voltage is below to the capacitor voltage, that time the diode will be turn off, because this one is a higher value, this one lower value. If I take this one as a value alpha at angle, some angle, this, that time the capacitor voltage is below to the source peak voltage, and that time this one, that capacitor will charge. After that this one discharges like exponentially, because of the this one circuit is absent. Okay. When the capacitor is charged here, this is the peak value of the source voltage. This one peak, it means capacitor will charge this one voltage. When supply voltage decay from peak to 0, that time capacitor will be charged, and capacitor voltage is greater than the source voltage. That's why this one circuit is disconnected, and capacitor circuit supply to the voltage here, supply the current load to the load. It means this one is the charge time, and this one is the discharge time of the capacitor. After in new cycle, here is after this one charge capacitor, after discharge, and discharge, charge, and discharge. It means output voltage is like that. This one is the middle of this one, Raoult's own shape. This one. This will be not good. This one is the output voltage, actual output voltage. This is the charging time of capacitor, and this one is discharging time of capacitor. I take this one as a beta, discharging time, and this one is the alpha, when the charge the capacitor, and charging time is this one. If you look here at the waveform, if I take this one as 0, and peak to peak is the 180 degree, this one is a pi, and peak to peak of the sinusoidal is a 180 degree. So in the output voltage is 180 degree, this one. That's why this was if conduction time is beta, then this time and this time is the same charging, and you can say this one is alpha also. Then alpha is equal to pi minus beta. And what is the voltage of this one? When the capacitor voltage charges. This one matches in this. You can say Vs, this is Vm sin omega t. So okay, at omega t is equal to alpha, and that angle alpha Vs is equal to V minimum, V naught minimum. You can say V minimum. This one V output bit by V minimum is equal to Vm sin alpha. This one Vm sin omega t, and this one is alpha, and alpha is equal to omega t is equal to alpha, and V output is a V minimum. Then alpha you can say sin inverse V output minimum to Vm. During discharging time, this circuit, only this one circuit is present, RC circuit, and capacitor have some voltages. This is initial voltage, and what is the I? You know, if the initial voltage is present in the capacitor, then I is equal to V by R e power minus t by tau, where tau is RC. Then you say I is equal to V C divided by R e power minus t by RC. This one is the discharging time. At a discharging time, in this period, only capacitor and resistor circuit is present. Capacitor supplied to the load power supply. So from 0 to, look here, can change the notation of this one? If you take this one as a 0, and this one is the pi, and this one 0 to TD, this one discharging time, same as a beta angle. Then you say omega TD delay time is if you observe this one, this is a pi by 2 angle because of this one pi and half of the maximum, and this one is a pi by 2 here and pi by 2 here, and this angle is the same alpha. Then you can say this one also alpha. Then discharging time total here to here, you can say pi by 2 plus alpha total. This one a pi by 2 half of half one, and this one is the same angle because of this one alpha, and this one also alpha, pi by 2 plus alpha. So omega TD is pi by 2 plus alpha. And find TD is equal to pi by 2 plus alpha divided by omega, the discharging time. And at omega TD, you know V naught, you know about the V naught is equal to IT into R, you can also say like that. R, this one is the VC is equal to Vm is the initial value. If you take an initial value here Vc, then V is the maximum value of the sinusoidal. You can say Vc is equal to Vm, because this maximum value is the initial value of the capacitor during the discharging time. You can say Vm r are cancelled out, Vc by r e power minus t by tau, it means Rc, and time at t is equal to Td after discharging, and find V output is equal to Vm e power minus Td divided by Rc. Then this one value add t0 to Td, this one is Td time period, discharging time, this one is the same, and you can say this one is V output minimum also, as at a Td, and V output is the V output minimum, the same as this one. And now you can also find here V output minimum, Vm sin alpha, Td by Rc, you can take a ln Vm is equals to left side V output minimum divided by Vm, the same take a ln log and we find V minimum to Vm minus Td divided by Rc, and ln the negative, if you take a negative value here, then you find a Td is equal to Rc, and here the opposite to the denominator and denominator interchange for the negative value, then find Vm is equal to Vm divided by V naught minimum. Td and Td here also fine, then you can say equal to the this one pi by 2 plus alpha divided by omega is equal to Rc ln Vm divided by V output minimum, and given the C, you find the C value, then C can calculate from here pi by 2 plus alpha divided by omega r into ln Vm divided by V output minimum. You can calculate the output capacitor value for the filter of the V output delta Vr ripple in the output is the same as here, this one to this one. This one is the Vm value, peak value, output peak value is the same as the Vm output, source voltage peak value. This is the output minimum value. Then this one is the delta Vr. Can say Vm minus V output minimum. You can calculate V output minimum here, from here, and put this one is given, Vm also given, V output minimum you can calculate, and putting value here alpha is also you can calculate sin inverse V output minimum divided by Vm. I think for output voltage, average output voltage calculation, for approximation value you can take the same as a V output maximum plus V output minimum divided by 2. This is the same, this is not much change, in the approximately same value of the V output voltage. And you can, if you want to find actual value, then you integrate this one, find the average from here to here. You can calculate from here to this one. Yeah, you start from the 0 here, then this one is a Td, a beta value, and this one is next one sine value from beta to pi. This one the one cycle. Now you take this one like that, this one is the one cycle of the output, and then after that this one repeated. and this one is the 1 cycle. First this one is the TT beta. After that this one is a pi in 0, this one pi, and this one beta to pi you can calculate. Now you can simply find the V output average is the V output maximum to V output minimum divided by 2. And if you find a V output average, then you find easily resistance of power is given V output square divided by P. The output if you can find here, and power is given, and find R value omega is equal to 2 pi f. Frequency is given 50 hertz. You can calculate it. If you can do everyone this one calculation.
Excuse me.
Can do this.
But it has asked for RMS current, average diode current. A lot of questions are there in that problem.
What is the RMS value?
RMS value calculated na, this one and this one. You can okay. Okay. I see RMS. I see. Don't worry. I see RMS means you have a two RMS IC current. When this one is flow from IM minus I naught. This one IM is given, I naught you can find, V naught is find, power is given, then you find I naught, IM minus I naught is given, you can find, and this one is the current flow to the IC. This one is, if this one is I naught, this one is IM, then this one is current flow na IC, and now you can say na IC is equal to IM minus I naught. It will flow when this one only for this alpha 2. Yeah, you can say this one is, if you take this one 0 and this one is beta, I will take this one is beta, the beta to pi you can say, pi minus beta by. Can you understand this one?
Sir, here,
one second.
while charging also there will be current flow in C, and while discharging also there will be current flow in C.
I will explain. This one is part only charging condition. Discharging different waveform.
Okay.
Yeah, this one waveform like that, and this one.
Yes, sir. Yes.
If I taken this one is a beta you can find, and this one is a pi. If you take 0 to pi, then you say na this one is present when pi minus beta times. This one is beta, this one is pi minus beta, this one is present when charging condition, this one is a charging waveform.
Yes, sir.
Then this same as IC when discharging, this one is only resistance is present. Na, this one only, this one is 0 at discharging condition. This one is 0, only I naught present. If I naught present, then I naught only present this one for the period of beta only.
Yes, sir.
Then for calculation of RMS, take square root IC RMS. This one IM minus I naught, what a time, pi minus beta divided by pi, total time period is pi, 0 to here, this one the other cycle repeated, sorry, this one is square plus I naught square, total time beta divided by pi. Can you calculate this one like that? I naught, you have I naught, I am also given, beta time, this one you can calculate it, and pi is, you know about that, 3.14.
But how to get the function of this discharge period and rising time? how to get the function, because for getting the RMS value, we need the function.
Yeah, if you calculate from the function, then you know a current expression, this one. You can square this one and 0 to TD time period. This one is the function of discharging.
This, okay. And while this is the discharging function,
Yeah.
and what will be the charging function?
Charging the same Im sin omega t na V naught by R.
I sin omega t, okay.
Because this one is sinusoidal, na?
Yes, sir. Yes,
It's the same current flow.
Yes.
Vs by R. And the diode current? When a diode is present in one diode, this one is the D1, D2, this one D3, D4. But here only this time period diode is present. Look here, all of time this one capacitor is present. Capacitor charge, capacitor give the supply to the load, and capacitor charge only this time period. And at this time period only a diode will turn on. Diode conducted only for this one time period. It means alpha. If you find a diode average current ID, then you can say ID present Im into alpha by beta, Ip by pi is on the average. And same if you calculate the RMS, then root this one and square this one, RMS value. For the average diode current, Im is given. This one Im only this one is flow through the diode at a time of alpha time period, and Im into alpha divided. Yes,
Sir,
yes.
cannot we calculate the RMS value by simply Im is the peak value, RMS we know, into alpha upon pi, IRMS into alpha upon pi during that charging period.
This is not a given maximum source current is an Im. This one is the Im is the current. This is a peak current. This is not a peak current.
This will correspond to the sinusoidal wave, no?
Yeah, if you take it to sinusoidal, then you calculate all of things like that. Then Im by root 2 you can also take.
Sir,
Yes.
here Im will be the peak current flowing through diode, na? At the time of alpha, after alpha. Here the current through diode is not shown in this waveform. Actually, it is not sinusoidal. It is different than sinusoidal.
No, this one is the sinusoidal. In charging condition, this one is the sinusoidal.
This will be there for the alpha.
Yeah, this one alpha time period.
Alpha time period.
It is sinusoidal.
Yeah, this one is sinusoidal.
No.
It will be only for alpha.
For the conducting period of the diode, it is only the period when the peak current flowing for the charging, it will be shaped different than the sinusoidal. This is not sinusoidal.
No, this means this one is the output voltage. If output voltage, I will take
These
current.
These are voltages and these are sinusoidals. But current flowing through diode is not sinusoidal.
I think during the alpha time, the current will be, the function can be decided sinusoidal.
No, he was correct. This was not a pure sinusoidal. You can't say like sinusoidal.
Never.
Because the charging current of capacitor is not same.
It's a kind of peak waveform, sir. Only at alpha.
Yeah. This one can peak. That time this one I think he given it, this one. That's why IM is given and simple calculate like that only.
It will be seen through simulation. Actually, it will be
This
seen
one is
through
spike
simulation.
given.
Spike, yes.
That's some spike coming. That's why we take this one only at the average. You can't calculate the exact IM what is diode current. That's why IM is given, then take this one for average.
It will be not numerical. Can we calculate, or we have to see through simulation?
Yeah, we can calculate, na. I think simulation is some different file.
Sir, average is now IM alpha upon pi. What is the RMS?
If you take for RMS, then take RMS and square of this one. This one equals. Sorry. I think this one not a pi. For one diode, a single diode. This one connected to diode. This one another diode. You understand what I mean? And this
D1
one,
and D2.
yeah, this one D1, D2, but this one is the D3, D4, and D1 is on only. This one only out of the 2 pi, not a pi.
Not pi, yes.
That's why I taken a 2 pi.
2.
Yeah.
So it will be IM square or IM into pi alpha by 2 pi.
Yeah. Okay, I am stopping here.
Okay. Wait.
Mm-hmm.